This video lesson is on electrochemistry. This is part one of our study of electrochemistry. We first want to define electrochemistry. So exactly what is electrochemistry? Well, from the name you can tell that it has to do with electricity and chemical reactions. So it's the study of the interchange of chemical and electrical energy. This type of reaction involves a redox reaction. Remember from chapter 4, redox reactions are reactions that involve both an oxidation and a reduction reaction. So we're going to revisit that concept in this unit. This is the type of reaction that occurs in a battery. There are two types of electrochemical cells that we're going to study in this unit. We have galvanic cells, which are also known as voltaic cells. In these type of electrochemical cells, you have a spontaneous redox reaction taking place. The second type of electrochemical cell is called an electrolytic cell. In an electrolytic cell, a non-spontaneous redox reaction is occurring. So in order to power an electrolytic cell, you do need an outside power source, such as a battery. Let's look at some vocabulary that we need to know for this unit. Going back to redox reactions. So remember from chapter 4, we learned that oxidation occurs when an atom loses electrons. During this process, the element attains a more positive oxidation state. So, for example, here we have sodium, solid sodium metal. If it were to undergo an oxidation process, it would form the sodium ion and it would release one electron. So the atom is losing electrons. You'll notice the electrons are on the product side because it lost the electron. Remember, a way you can remember the definition of oxidation is remember if it loses electrons, it oxidizes. Reduction occurs when an atom gains electrons. In the gaining of electrons, the element attains a more negative oxidation state. Here we see a nonmetal chlorine, diatomic chlorine, picking up 2 electrons, one for each chlorine, and that forms 2 chloride ions. So notice here it's gaining an electron, and so you see the electron on the reactant side of this reaction. So remember, with reduction, if you gain electrons, that means it is reduced. The substance was reduced. Now, I know that that sounds sort of counterintuitive, gaining electrons, but you're reducing. But what's happening is the overall charge is what reduced. It got negative because it was neutral and now it's negative. It has a more negative oxidation state. Now, to help you remember and differentiate between these two concepts, if you will, or these two processes, remember this saying, Leo goes grr. Now, Leo is a lion, and of course, lions growl. So remember, Leo goes grr, and that helps you remember the definitions. Leo stands for lose electrons, means you oxidize, as we said up here, L-E-O. Grr helps you remember that if you gain electrons, you're going to reduce. So gain electrons means reduction has taken place. The next thing, as far as vocabulary, you need to be familiar with redox reactions, we talked about this also in chapter 4, is the concept of oxidizing agents and reducing agents. The oxidizing agent is the substance that is reduced. Now, it is the agent that is responsible for the oxidation taking place. So in the process of oxidation occurring, the substance itself gets reduced. This concept can be a little confusing to students, but I do have a little way to help you remember it in just a few minutes. The reducing agent is the substance, and these substances, class, are the reactants. So I do want to clarify that. The agents have to be reactants in the reaction. So it's the reactant that is oxidized is the reducing agent. Think of these in terms of like secret agents, like a spy. The agents are responsible for allowing or helping the opposite process to occur. So if it were not for the reducing agent, reduction cannot occur because the substance itself is oxidized. And by being oxidized, it is losing an electron so that the reduction can occur by the other substance. These two processes, oxidation and reduction, goes hand in hand. A couple of more definitions are anode and cathode. The anode in your electrochemical cell is the electrode, which is going to be like a metal surface. I'll put here this surface. It's the electrode or the metal surface where oxidation is occurring. The cathode is the metal surface where reduction is occurring. The anode and cathode are in separate half cells. Now, here's another memory device for us to help us with some of these terms that relate anode and cathode with oxidation and reduction. So remember the saying, an ox and a red cat. The anode is where oxidation occurs. The reduction will always occur at your cathode. So you've got an ox and a red cat. Hopefully that will help you remember that. Here we see a table of reduction potentials, and we will use these in some of our calculations that we do in class. This is a table of standard reduction potentials, and it, as with all of our reference tables that we use that are in our appendix of our textbook, this is measured, like these values are measured against a standard, and in this case it's the standard hydrogen electrode. This is like our reference point. Notice that for the standard hydrogen electrode that it is arbitrarily assigned a potential voltage of 0 volts. Here you see volts is your unit, and this little symbol here is kind of hard to tell on this screen, but it stands for the cell potential. It's like a E with curly Q's on it, and there's your standard. The degree sign means it's standard conditions, which is 25 degrees Celsius. This is a table of reduction potentials, so they are all written as reduction half reactions. Notice all of these have the electron as a reactant. Now for our calculations, you're going to have an oxidation and a reduction reaction that's going to be occurring. So when you pull your values and your half reactions off of this chart, one of them will stay as a reduction, but the other will be reversed, and it will become an oxidation half reaction. And we'll look at how to get all of that to work out in some examples in a few minutes. All right, so the first type of cell I mentioned was a galvanic electrochemical cell, the voltaic cells. These are cells where you have a spontaneous redox process taking place. So a couple of things about spontaneous redox processes you need to know. They have positive cell potentials. That's that little E, the cell potential. And the cell potential refers to the pull that causes the electrons to travel from the anode to the cathode. It's called the electromotive force, and it's a pull that allows the electrons to travel from the anode to the cathode. And it is related to the electronegativities of these elements involved. We measure cell potential in volts, and that symbol for volts is a capital V. And remember from the thermodynamic unit that as far as free energy goes, a negative free energy change means the process is spontaneous. So we're talking about a spontaneous redox reaction. So that means that the spontaneous redox reactions are going to have a negative delta G, or negative Gibbs free energy change. This is a general setup of a electrochemical cell.